Welcome student. Today we will study probability. Concept of probability like probability mass function, probability density function, expectation and variance. These are the topics which we are going to study in this particular lecture: probability mass function, probability density function, expectation and variance. But before going to these topics, just we come to know what is random variable. Random variable is a variable whose value is numerical outcome of any random phenomena. Random variables are of two types. Number 1, discrete variables. Number 2, continuous variable. When a variable is known as discrete variable, when random variable whose value is obtained by counting. Counting means when we throw a dice, then 1, 2, 3, 4, 5, 6, out of these 6 one may occur. So, it is known as discrete variable. What is continuous variable? When we take example of a class in which we take height of a student, then now height is not a discrete value, it is a continuous value. So, two types of random variable is: first is discrete random variable. X has a countable number of possible discrete values, while second one is a continuous random variable. It is a random variable where the data can take infinitely many values. Now, next, first topic is probability mass function. If our random variable is a discrete random variable, then what is probability mass function? Probability mass function is a function over a sample space S of a discrete random variables having the values x1, x2, x3, x4 etc., which gives the probability p equals to a certain value. Now, probability mass function f x is equals to p of x at x is equals to x k. Basically, probability mass function must carry at least two conditions. First condition is f x must always be greater than or equals to 0 for all values of x k, and second condition, which is a basic condition, that summation of all f x is equals to 1 over the sample space. If our function satisfies these two conditions, then that function is known as probability mass function. Now, how we represent probability mass function? Probability mass function be represented in either of the three forms: as a form of formula, as a form of table, or as in a graphical form. If x have values 1, 2, 3, 4 and their probabilities are 0.22, 0.31, 0.21 or 0.26, then we can write probability mass function in this particular tabular form, or we can generate graphical form of this probability mass function, or we can also write down probability mass function in the form of a formula. Some related concept of probability mass function. Probability mass function may be a joint probability mass function. When our vector is a random vector, then obtained probability mass function is known as joint probability mass function. Second type of mass function is marginal probability mass function. When probability obtained by considering only a subset of the set of random variables forming a given random vector, then obtained mass function is known as marginal probability mass function. Third type of mass function is conditional probability mass function. If there are some conditions, that is probability mass function obtained by conditioning on realization of another random variable. So, these three types of probability mass functions are also studied in this mass function phenomena. Let us take an example to better understand what is probability mass function. The question is, let S be the set of integers and f x be defined as f x is equals to k within bracket 7x plus 3 if x having value 1, 2, 3 or 0 otherwise. Find the value of k if f x is a probability mass function. Now, let us see, if this f x is probability mass function, then it must hold two values. Number 1, two conditions. Number one, f x is always be greater than or equals to 0, and second condition is sigma of all f x is equals to 1. Now, from this formula we can easily see that f x, the first condition f x, as x is 1, 2, 3. So, this is always be greater than or equals to 0 if k is positive. If k is positive, then first condition of probability mass function hold, and for second condition. Now, for second condition, sigma of f x is equals to 1. This is the second condition for a function to be a probability mass function. Sigma of f x. Now, f 1 is equals to how much? K times 2 x plus 3. F 2 is equals to k times f 1 is k times 1 x plus 3, f 2 is k times 2 x plus 3, and f 3 is k times 3 x plus 3. So, second condition is we add all these three value f 1 plus f 2 f and f 3, this must be equals to 1, that 1 is equals to 7 plus 3 times k, 14 plus 3 times k, and 21 plus 3 times k, which is equals to 51 k. So, the value of k is equals to 1 upon 51. Now, come to again the question, if f x, the given f x is a probability mass function if k is equals to 1 upon 51. Now, second topic, second point is probability density function. Well, probability mass function is applicable when our variable is discrete variable, like as a case of dice or cards, but if our discrete variable is a continuous variable, that is we take a case of temperature or case of height etc., then that on those conditions obtained function is known as probability density function. What is a probability density function? Let x be a continuous random variable. The probability density function is the integral value of f x over the limit a to b, which is also equals to p, where a and b are any real number. Now, what is probability density function? Probability density function is integral a to b f x dx, if this is our f x. Now, in this case you can also see this if we are integrating this particular function f x, then this would provide you area of that particular region. There are again two conditions of probability density function as well. The first condition here, this f x must be greater than or equals to 0. The function value is must be greater than 0, and second condition, as our function is a continuous function, this type of function. So, integration over the whole limit from minus infinity to plus infinity, minus infinity to plus infinity f x dx is equals to 1. These two conditions are very similar to the condition as we study in probability mass function. What is the difference between these two conditions? As this function is continuous variable function, so we are integrating this particular f x dx in probability mass function, we just take summation of all values. Now, examples of probability density function. You might heard about normal distribution, which is a very popular example of probability density function, but not only normal distribution, other distribution like uniform distribution, exponential distribution, gamma distribution, all of them are probability density function. This is probability density function. Why? Because it is satisfying two conditions. Number one, f x is always be greater than or equals to 0. As we say, this f x for a continuous different distribution, f x is equals to 1 upon b minus a. Here b is greater than a. So, obviously for all values of b and a, if b is greater than a, this function must be greater than 0. The first condition hold. What second condition? Second condition is integral over the limit minus infinity to infinity f of x dx, that is equals to 1. You can easily verify this, the integral minus infinity to infinity f of x dx, f of x is 1 upon b minus a dx, this is constant over here and function is defined between a to b only and otherwise it is 0. So, this would become minus infinity to 0 minus infinity to a to b plus b to infinity. Now, these two integrals become 0 and our obtained result is minus a to b 1 upon b minus a times dx, and this is equals to same as 1 upon b minus a x a to b. When we substitute limit, it would comes to 1. So, this uniform distribution is probability density function because it satisfy these two conditions. Other distribution like exponential distribution, gamma distribution, normal distribution, you can very easily verify all these distributions are probability density function. Now, we do solve a question on probability density function. So, let us take this particular question. Suppose that random variable x has the function f x is equals to theta plus 1 x to the power theta, where theta x varies between 0 to 1 and it is 0 otherwise, where theta is greater than or equals to 0. Verify f x is the probability density function. If we like to verify our f x is a probability density function, then it must satisfy two conditions as we discussed previously. First condition is f x is greater than or equals to 0. As we know that theta is greater than 0 and x is lies between 0 to 1. So, theta is greater than 0 and x is also be greater than 0. So, this function f x is equals to 1 plus theta x to the power theta is always be greater than 0. First condition of probability density function hold. Now, what is about second condition? Second condition is minus infinity to infinity f x dx. What is second condition? Second condition is minus infinity to infinity f x dx is equals to 1. Now, f x is equals to theta plus 1 x to the power theta for value x lies between 0 to 1. If we put value of this function in this condition, then f x is equals to theta plus 1 x to the power theta and limit here is minus infinity to infinity. So, first we break our limit minus infinity to 0, 0 to 1 and 1 to infinity, and function is 0 otherwise. Otherwise means when x is less than 0 and when x is greater than 1. So, these two parts give you 0, value 0, and value of this integral 0 to 1 theta plus 1 x to the power theta dx, this is equals to theta, as we are integrating here with respect to x. So, theta is constant, take it outside x to the power theta, and integral of x to the power theta is theta to the power x to the power theta plus 1 upon theta plus 1. These two theta plus 1 cancel out, and when we substitute limit, we would get value of integral is 1. So, f the given function satisfy both condition of probability density function. First condition f x is greater than 0 as obvious, second condition f x is equals to 1. So, this function is known as and treated as probability density function. Hope you understand these two concepts of probability density function and probability mass function. One is probability mass function is used when our variable is discrete variable, and probability density function is used when our variable is continuous variable. Next concept of this lecture, next topic of this lecture is expectation. What expectation means? It is as simple, the word means expectation. In mathematical, expectations means weighted average. What do you mean by weighted average? Just see, go in detail when we solve a question later on, but just see the definition of expectation, The mean value of the probability distribution of a random variable is commonly known as expectation and denoted by e to the power x, means the mean value. The mean value of the probability distribution, in short known as expectation. As our variables are of two types, discrete variable or continuous variable, so expectation formula for both are bit different. If our function is variable is discrete variables, then formula of expectation is xi f of xi and summation of all these value. And if our function is continuous variable, then expectation formula is minus infinity to infinity x f x dx. This formula is applicable when our function is fx is probability density function. When fx is probability density function, then this formula is acceptable, and when our function is probability mass function, then this formula Ex is equals to sigma of xi f of xi. The properties of expectation, they are simple property of expectation. Basically they are algebraic properties of expectation. Capital X is a random variable, capital X or capital Y is a random variable and A is a constant. Then what is the first is linear property. What is linear property? E of expectation of Ax is equals to take A outside of this E. Basic linear property, expectation of Ax plus y is equals to A times Ex plus E of y. Expectation of constant, if C is a constant, then expectation of any constant quantity is always be the same, is equals to C. And if the random variables are multiplied, then expectation of product of multiple is defined by this particular rule. Conditional expectation, if there are two variables and there is a conditional probability between two random variables, then expectation of these random variables is equals to x multiplied by conditional probability. Basically we can say expectation is x multiplied by probability in general, whichever type of property we try to study same. The concept of expectation is equals to x multiplied by probability mass function or probability density function. To better understand this expectation, we just see these few examples of on expectation. Now first one is, what is expected value when we roll a fair dice? When we roll a dice, then what is the expected value? What is expected to be come out numerically? Now here you can understand the what is the concept of expectations. So a die is rolled, then possible outcomes are 1, 2, 3, 4, 5, 6 and each have probability 1 by 6. This is a basic very elementary concept that if die is rolled, then probability of every number is 1 by 6 and expectation. Now what is expectation? The formula of expectation is sigma of xi f xi, means first variable outcome is 1, probability of 1 is 1 by 6, second outcome is 2, probability again same, third, fourth, fifth and sixth. So what is expectation? Expectation is equals to 1 multiplied by 1 by 6 its probability, 2 multiplied by its probability and so on. When we add and simplify all these things, we would get 3.5. Now expectation of fair dice is equals to 3.5. Now what it means geometrically, and to better understand, we just go through this particular image. This is our first value 1, second value, third value, fourth, fifth and sixth. Now there are in our event or experiment for 6 outcome is expected and each having probability 1 by 6. 1 probability 1 by 6, 2, 3, 4, 5, 6. Now what is weighted average? Weighted average means the point along which this whole geometrical system would be balanced, or you can say center of mass type of thing. Now, center of mass is just mid between 3 and 4, and what is the mid value of 3 and 4 is 3.5. So, expectation of function this rolling of field die is 3.5, 3.5 is the expected value. Another question on continuous random variable. Find expectation if probability density function f x is equals to 2x, where x is lies between 0 and 1. Now, we try to find out expectation of a function f x is equals to 2x and x varies between 0 to 1. The formula of expectation, if we take this function is probability density function, continuous function, then expectation formula is x into 2x. Now, integral formula is x into f x. As we just see previous slide, we have this formula minus infinity to infinity x of f x. This is the formula of expectation for continuous distribution or continuous probability density function. If we use this formula from minus infinity to infinity x of f x, here x vary between 0 to 1. So, first of all we break our limit from minus infinity to 0 plus 0 to 1 and plus 1 to infinity. Now, function is defined over the value 0 to 1 and rest we can consider it as 0. So, these two integral would become 0 and function expectation x times f x is equals to integral 0 to 1 x times f x dx, 2x square, and integral value of 2x square is 2 by 3. Now, this expectation 2 by 3, what does it means? It means if we take a geometry of this function over this coordinate plane, this is 0 and this is a point 1 comma 2. Now, this function f x is equals to 2x represented by this particular function. Function have a value from 0 to 1. Function is defined between the value 0 to 1 and function is of this type. Now, expectations comes to 2 by 3 means what? Means if we take a geometrical shape of this particular triangle, then center of mass of this geometry will lie at this particular point 2 by 3. Now, what expectation means? Expectations means the weighted average of the function. Next slide. Next topic is variance. Variance is known as how much your data is spread about a particular the variance describes the spreadness around the expectations. We have two type of function, continuous distribution and discrete distribution. Same, the formula for continuous distribution of variance is equals to x minus mu to the whole square f x dx, and variance for discrete distribution is sigma of x minus mu whole square f x dx. Means this is almost parallel that with expectation formula. Here x minus mu to the whole square. This formula can be transformed in this particular way. Variance of function is equals to expectation of x square minus expectation of x to the whole square. Properties of variance. Variance means spreadness of data. Spreadness of data, if data is constant, then there is no spreadness of data. So, variance is equals to 0. First property. Linear property, variance of a x plus b, as variance of b is equals to 0. So, this is equals to variance of a square. By derivation, if we go through derivation, so we can get a square times variance of x. and variance of two variable x and y are addition or subtraction of those variable. Now, just go in questions on variance. Find out variance for the following data: x is equals to 0, 1, 2, 3 and their corresponding probability is 0.1, 0.2, 0.4 and 0.3. To find out expectation, first we find out variance, first we find out expectation, and mu is equals to, expectation is these digits multiplied by their probability, which is 1.9, and variance is equals to x minus mu. First random variable is 0, 0 minus 1.9 whole square multiplied by 0.1, and next is x is equals to 1, 1 minus 1.9 whole square and so on, and when we calculate all these value it comes to 0.89. This is variance of x. Another question, the variance of f(x) if f(x) is equals to 2x to the power minus 2, this is a for continuous random variable. Now, we use this particular formula, variance of x is equals to expectation of x square minus expectation x to the whole square. Expectation of x square is equals to minus infinity x square f(x). What is f(x)? 2x to the power minus 2, which gives you value 2, and expectation of x is equals to x into f(x), which is equals to 2 log 2. Now, variance of this continuous distribution is e of x square minus ex to the whole square. Numerically, when we substitute values of these two expectation, then our variance will become this particular value 0.0782. I hope you can understand the concept of probability density function, probability mass function, expectation and variance. They are very important concept, theoretical concept of probability and very useful tools in statistics. Good luck for your coming examination and your for further studies. Thank you, beta.